My name is G. Shanmugapriya, working as an Assistant Professor of Physics in V.V. Vanni Perumal College for Women, Virudhunagar. Now I am going to discuss about the semiconductor. So what is semiconductor? A semiconductor is a material whose electrical properties lies in between those of insulators and good conductors. The best examples for semiconductors are germanium and silicon. And the semiconductor can also be defined as those materials which have empty conduction band and filled valence band. And the energy gap is in between these two are 1 electron volt. So this is called as semiconductors. So semiconductors can be classified into two types. So first one is intrinsic semiconductor, then second one is extrinsic semiconductor. Again the extrinsic semiconductor is of two types, that is p-type semiconductor and n-type semiconductor. Now I am going to discuss about the intrinsic semiconductor. The intrinsic semiconductor is a one which is made up of material and it is a pure form of semiconductors. So what is meant by pure form? That is no impurities added to the semiconductor. That is the pure form of semiconductor. The best example for pure form of semiconductor is germanium and silicon. And the energy gap is 0.7 electron volt and 1.1 electron volt. So here it consists of two valence band, that is valence band and conduction band. So the lower part is called as valence band and the upper part is called as conduction band. Then the Fermi level, that is the band gap between these two bands is for germanium 0.7 electron volt, then silicon 1.1 electron volt. Then extrinsic semiconductors. So the extrinsic semiconductor means that is a impurity is added to the pure form of semiconductor to increase the conductivity of the materials. So we can add the impurities in two ways, that is we can add pentavalent impurity and trivalent impurity. So depending on the type of doping material added, so the extrinsic semiconductor can be divided into two types, that is n-type of semiconductor, then p-type of semiconductor. So n-type means negative type of semiconductor, then p-type means positive type of semiconductor. So first I am going to discuss about the n-type semiconductors. So this semiconductor is obtained by using a pentavalent impurities. So the best example for pentavalent impurity, antimony. So here the antimony is added to the germanium crystal. So each antimony atom forms covalent bonds with the surrounding of germanium atoms with the help of 4 of its 5 electrons. So the fifth electron is superfluous and it is loosely bound to the antimony atoms. So that excess electron is denoted as a donor electrons. So here in n-type materials, so the excess electrons is heavy, so it is called as majority carriers. Then next type is positive of semiconductors. So here boron is added to the pure form of semiconductors. So here trivalent impurity is used to increase the conductivity of semiconductor. So here boron having outermost electron is 3, then germanium having outermost electron is 4. So here we can join the two boron and germanium means, so the one electron is vacancy, that is here hole is created. So here it consists of majority numbers of holes. So these are called majority carriers and minority carriers. So what is majority carriers and minority carriers means? So in the positive type of semiconductors, so holes are heavy number, so that is called as majority carriers, and electrons are lesser number, that is called as minority carriers. So in n-type semiconductor, the electrons are majority carriers and holes are the minority carriers. Then by using the principle of p-type semiconductor and n-type semiconductor, we can make a diode, that is p-n junction diode. So what is p-n junction diode? That is p-type of material is added to the n-type of material. So that process is called as doping. So what is doping means? The joining of p-type material to the n-type materials to increase the conductivity of the semiconductor. So here we can join the two materials by using germanium or silicon crystals. So the p-type material is referred to as a anode and n-type material is referred to as a cathode. Then the arrowhead indicates the conventional direction of current flow when forward biased, and it is same direction in which hole flow takes place. So here the PN junction diode consists of two regions, that is P region and N region. So the positive type is always called as anode and the negative type is also called as cathode. Then working and VI characteristics of diode. So what is working of diode means the joining of p-type material to the n-type materials. So there is a recombination of electrons and holes. So here some voltage is developed across the junction. That junction is called as PN junction. So here the p-type material is connected to the n-type material and it acts as an conductor when it's forward biased, and it acts as a reverse biased, it acts as a insulators. So this diagram shows the forward characteristics and the reverse characteristics. So forward characteristics means when the voltage increases, then the current also increases. When reverse bias, the voltage increases, at certain point the current decreases. So that is called as reverse biasing. Then there are various types of diodes available in the market. So here I mentioned some diodes, that is light emitting diode, laser diode, avalanche diode, Zener diode, Schottky diode, photodiode, PN junction diode. So these diodes are used for many applications. So here I mentioned some applications. So first one, the diodes are used in clamping circuits for DC restoration. Then it is also used for clipping circuits for wave shaping, that is clipper circuit and clamper circuits. And these diodes are used for the voltage multipliers, and it can also used as a switch in the logic gates. It is used in the demodulation, optical fiber communication, digital displays, and it is also used as a voltage regulator. Thank you.